So to continue with morphine, these are the class of compounds, and they're very useful painkillers, but they have addictive properties, except for codeine, of course. So if you look at the structure also, it's very, very complicated structure. Actually, there is oxygen missing in here, in this structure. So even though it's possible to make this synthetically in the lab, that's not done because it's many, many steps, and the yields are not high. So these compounds are isolated from plants. What they've noticed though is chemists have looked at structure and compared the activity, and this is called like a structure activity relationship study, in which they ask themselves, does everything in morphine necessary to produce the painkilling effect, and what aspect of the structure might be causing the addictive properties? Because ideally, if they could come up with a painkiller that does not have the physical dependence, that would be the ideal drug. So that's how they actually came up with other painkillers, such as Demerol and methadone. What they found over studying hundreds and hundreds and hundreds of compounds is that what was necessary for the pain-killing effect was that the quaternary carbon was, this carbon with 4 groups was needed, and then off of that phenyl group was required, and then 2 carbons away you needed a tertiary amine that's got the 3 R group attached to it. So by looking at many candidates that look similar to morphine, this is what have come out as what worked. So Demerol is widely used as painkillers, and methadone is actually used as a treatment for heroin addiction, because it has a similar effect as heroin, but it doesn't have the addictive property. All right. So, and on a side note, what people have done also in the dark side of chemistry is that people have been trying to make synthetic heroin, which is this compound with the phenyl group here and an ester group coming off at that quaternary carbon, and nitrogen 2 carbons away. So this is the synthetic heroin, and this was made in underground labs by doing an acylation reaction. So this all should be familiar to you because you just learned this chemistry. And what they did was they took this compound, which was readily available back then, and took that alcohol and did an acylation reaction to make this ester. All right, and they sold it as a synthetic heroin. What happened in one instance was that not only whatever the condition that they're using, not only did it acetylate, but it also, after it acetylated, there were small contaminant of eliminated product, which is this. So imagine this ester with the hydrogen leaving, which is, you know, pretty good leaving group, and making an alkene. And one of the batches that underground chemists have made was unknown to them. Most of this compound, like 97% of it, but it was contaminated by 3% of this compound. And what they found was people who bought this batch of drug and took it, over a very short amount of time, a week or so, develop sudden onset of Parkinson's disease, which has never been seen before. So they were developing tremor, increased stiffness, faulty body coordination, and they were increasingly becoming a zombie-like person. And this is all due to degeneration of nerve cells at the base of brain, which is what happens very, very slowly in our Parkinson's disease patients. But what was happening was this contaminant somehow, a small percentage of it was causing the Parkinson's disease-like symptoms overnight. And so the moral of the story is to obviously never, ever, ever trust anything that you buy on the street, because you don't know whether it is 100% pure. A lot of these labs don't have NMR to make sure the quality is good. They just synthesize it and you know, sell it. The good thing that came out of this tragic story is that now accidentally scientists know that this compound causes very quick Parkinson's disease, so they have a model in which now they give this drug to, for example, rats, and then which causes sudden onset of Parkinson's, and they have a good model for the disease to see if drugs that would treat Parkinson's disease actually work or not, right? So that really concludes the introduction to amines, and I could probably go on for another 2-3 videos worth of all kinds of interesting stories about different amines and alkaloids and how they are important. All right, so hopefully this brief 15-20 minutes introduction is giving you incentive to learn about amines, at least learn about the lingos and the terminology that's used for amines, and then also know the characteristics of amines and what kind of reactions they undergo. All right, so we'll start with the classification of amines, and that's going to be a very simple thing. So a lot of the amines are classified as primary, secondary, or tertiary, or quaternary amines. All right, so that is just strictly based on how many R groups are attached to the nitrogen itself. So for example, if you have one R group attached, that's called primary amine. If you have 2 R groups attached, that's secondary. And if you have 3 R groups, that's called tertiary. And then if you have 4 R groups attached, same or different, it doesn't matter. This is called quaternary. Oops, sorry. Quaternary ammonium salt. And because nitrogen is supposed to have only 3 bonds with a lone pair, when it has 4 things attached to it, it's going to have a formal charge of +1 attached to that nitrogen. So therefore, it's going to have some kind of counter anion, often a halide, associated with ammonium salt. And a lot of times the quaternary ammonium salts are abbreviated, for example, as shown here. And this would be triethyl ammonium chloride. That's what the name of this would be. But the 4th bond is with the hydrogen. So, but all these quaternary ammonium salts are named as ammonium, and then the anion. All right. So at this point, you should be able to, for example, in ecstasy, zoom in on the amine functional group, which is right here, and then ask yourself what kind of amine that is. So is it a primary, secondary, tertiary, or quaternary? So notice this nitrogen has 1 and 2 R groups, so this would be a secondary amine. All right. As far as naming goes, that's a pretty simple rule. So if you're naming amine as a parent, so in other words, there aren't other functional groups with a higher priority, which would be, you know, alcohol, aldehyde, ketone, any of the acid derivatives. Those are all have higher priority than amines. So then if those are present, then you would name the amine as a substituent. And so as a substituent, you would, so let me see, as substituent, you would name it as amino. All right. So this is when you have higher priority functional groups, and they're basically everything except for halide. Everything else, amine has a pretty low priority, so you would, a lot of times if you have multiple functional group, a lot of times it's going to be named as amino in a substituent way. But if only the halogens are present and everything is all alkyl or alkenyl group, then you would name it as amine. All right. So, but if you have alkyl groups on nitrogen, for example, primary, secondary, tertiary, they all have R groups on them, then you're going to name it just like you did in amide. So therefore you're going to have an N, some kind of alkyl group to indicate that the R group that you're naming is on the nitrogen itself. All right. So let's do a couple examples, and then we'll conclude this lecture. So let's try to name these two compounds and then draw this as well. So in naming this, notice there are no other functional groups other than amino group that are higher. So we're going to name this as the parent. So you have 1, 2, 3, 4 long carbon, and we're going to name this as phenyl. All right. So 4 carbon is butane, but because of the double bond is butene, and you are going to have because of the amine, and that's going to be your parent, it's going to be butyramine. And where's the double bond? At second carbon. And then you have at the 4th carbon a substituent called phenyl. So that will be the name, 4-phenyl 2-butyramine. It's understood in this instances that the amine group is at the end because of the name amine. It doesn't have an R group on that. All right, so we'll continue with the other naming in the next lecture.